Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present to you our research, which we choose topic 1, that is descriptive statistics, and our topic is drug addicts. Presented by the locus and guided by Dr. Sayang bin Muhammad Deni. So I will introduce our members. Firstly, my name is Mustaqim Huzaifi bin Syed Farisi. Our second member is Muhammad Faris Fahmi bin Abdul Rashid. And our third member is Nakiuddin bin Muhammad Sani. Okay. Let's go to the next slide. Okay, for introduction, drug addicts can have a destructive impact on society, often leading to crime, strained healthcare systems, broken families, and lost productivity. In contrary, we could solve the drug addicts issues by gathering statistical data on drug addicts categorized by age to take a step of prevention and leading a better understanding lifestyle in our society. Next. Okay, our objective is to determine which age group tends to be drug addicted the most. Secondly, to explore the impact of drug addicts number from drug recovery implications. And lastly, our objective is to examine the correlation between age and the onset of drug addiction. So this is our data introduction, which are collected. The data collection are based on this link from data.government.my that shows the data sample of 13,505 civilians across Malaysia that have been differentiated between age group and total addictors in 2023. So here is our. So I will pass on to the next member, please.
Okay, for this session, I will explain a little bit about our data set. First is the highlights from research, which is design details that have two. First, explanatory variable, which is age, and response variable and frequency, which is number of drug addicts. If we can see from the table, we have 5 categories of age, which have been grouped according to their age, and the numbers of drug addicts according to their age. And the data constructive, from the data set, we can determine the characteristics, which is the classes is equal in width by the age, and the classes is mutually exclusive because it doesn't overlap with other data, and the classes are continuous. For representation, the suitable graph frequency distribution is histogram. So from the table below, we can see the class boundaries, cumulative frequency, midpoint, and the frequency multiply with midpoint. Next slide. Now I will explain about measure of central tendency. In measure of central tendency, we will find 4 things, which is mean, median, mode, and mid-range. First, mean, we will find by calculate the cumulative of f multiplied with x, and we will get 392,775, and cumulative of frequency 30,505, and divide them, and we will get to 29.083672. The second one, median, we need to find the median class plus total frequency divide by 2, minus cumulative frequency before median class divide by frequency median class, and multiply with median class, and we will get 24.5 plus 6,752.5 minus 3,460, divide by 3,594, and multiply by 5, and we will get 29.08055. The third is mode, which is median class plus model class divide by model class plus before model class, and multiply with median class, and we get 24.5 plus 674 divide by 674 divide plus 320 and multiply by 5, we get 27.890342. And the fourth is mid range. We get the lowest frequency plus the highest frequency and divide by 2, and we get 540 plus 3594 divide by 2, and we get 2077. 2067. Next, I will give to my friend.
For the next, I will represent the measure of dispersion. Okay, for the range is to calculate the range between of the research of class H between the 30 largest value and the smallest value, which is 39, H39 and H15, which we get the range of H is 24 for this research. For the variance is to calculate the each variation of each class for the drug addicts. Okay, the formula is the summation of the n variable of x, which is midpoint, minus mean, and then we power by 2. And then we will get 271.63, and then divide by total frequency, which is 30,505, we get 0.02. Then we calculate the standard deviation, which is to determine the the result accuracy, which is the formula is square root of variance. We get 0.14, and then we will calculate the coefficient of the variation, which is the formula standard deviation divided by mean and times by 100, which is 0.49. Okay. So next, for the measure of squareness is usually to show how the shape of data will be skewed to the left or right. So we will use the Pearson coefficient of skewness, which the formula is 3 times of mean minus median, and then divide by standard of deviation. We will get 0. So in this case, the coefficient of skewness indicates that the graph will be like the most symmetry. We can look at the chart results, which is symmetrical on the mean, which is 29.08. Okay, so even though it's skewed to the left, but we will consider it's symmetrical because the mean and median did not differ much. Okay, so based on the histogram charts, we will conclude that the most drug addicts are from class range age from 25 to 29. The least drug addicts are from class range age 15 to 19. The drug addicts increase after the age of 24. The drug addicts decrease or decline after the age of 29. The shape of data, as I said before, the maybe skewed to the left, but median and mode didn't differ much, makes it the mostly symmetrical distribute. So the suitable central tendency to represent the data is median, because the median is represent actual data point in the data set, which is accurately calculated even without needing to know detailed data of the variables. So in conclusion, the dataset suggests that drug addiction is most prevalent among individuals around the age of 29. The symmetry indicates a tendency before the age of 29 and after are equally being affected. It also concludes that the drug recovery program does not as much big impact on the declination of drug addicts. So, understanding this statistical data can bring awareness to society in helping the prevention and intervention efforts to anti-drugs campaigns. So, that's all from the locals. Um, Thank you and very much.